because of, what's that guy's name? The guy who was a whistleblower for all the embezzlement scandals. Everybody trying to point the finger at him, but he had legal proof that he was not involved, and he actually pointed everybody out. They wanted to change Squaw Butte and a couple others, and he was like, well, it's part of history, even though it's kind of bashing us on the whole Indian side, calling squaws bitches.
But that's what they were called, though. That's what they called them.
That's what the French called them.
Yeah.
And it was a complete misinterpretation of their language. That's what the French Catholics who came down and started doing reforms of language, it was a misinterpretation.
Well, see, now, when I say they, I was just talking like my aunt's a squaw. That's what she called all of her. I mean, that's what she said. She's an unbreaked squaw. Maybe she was meaning it in a demeaning but matter. I don't know. It can be a little bit that way, but yeah, that's just what we grew up with.
Okay, guys. So guys and gals, thanks. Welcome to Lecture 25. We just had a little discussion here, so I thought I'd also let a few other folks out there know what's going on in the local news. So tomorrow morning, I am going to present to the Five Valleys High Performance Building Committee, Council, Commission, I can't remember exactly what they are, Consortium, and run through a variety of projects that I would like to do at 8 Columbine to turn it into a net positive house. So solar PV to make more electricity than it consumes, solar hot water so I can get off the natural gas grid, make hot water from the sun. I would also like to produce just fresh water, so get off the mountain line water grid as well, because that requires energy. I mean, right now we're using fossil fuels more or less to pump water back uphill to come back down into your house so you can turn on the faucet. But there's all kinds of water flowing through my property. In fact, right now there's a bunch of solid water sitting in my deck that could be put to use, drinking, cooking, cleaning, what have you. I'd also like to turn the house into a net positive for soil. So I've been collecting organic matter. Oh, thanks. Organic matter from my neighbors. So all the leaves, grass, dog poop, kitchen scraps go to the chickens. So I've been a sort of a carbon sink, if you will, in that sense. I've been able to sequester that carbon. Yeah, sure. Some of it goes off as CO2. If you don't aerate your compost pile properly, you can also get some anaerobic digestion, which is methane. However, there are some pretty cool technologies out there now for small-scale anaerobic digestion. You've probably heard of that a little bit. We talk about it a little bit more in 102. And also, if you take Brian Kern's courses, 241 alternative fuels and 244 bioenergy, you'll learn more about that. So anaerobic digestion, where you're purposely making methane to be used as a fuel, carbon-based fuel. But you're making it with carbon atoms that were very recently in the biosphere, not in the biosphere 100 million years ago, like the first problem that we solved here the first day of class. I would also like to move, and this is a little further in the future, but I also like to move 8 Columbine where hydrogen is used as an energy storage media, so using electrolysis to split water into hydrogen and oxygen, and then the hydrogen itself can be used as a combustion product for heating or cooking. It could also be used to make electricity through electrolysis. And if you were following the climate change summit meetings there in Paris, it sounds like they're going a lot better than in previous years. I think everyone's finally like, all right, it's for real. Maldives, Bangladesh, Miami, New York City, it's, this isn't some fantasy that people are talking about off thousands of years from now. It's like, going to affect our grandchildren. And I think there are enough forward-thinking people now, enough wealthy people. And Bill Gates got his pals together to throw some money around. Obama said he's going to double the energy research budget, federal energy research budget for next year. I was just speaking with someone yesterday coming out of Vancouver, BC, where they're going to shut down 18 coal-fired power plants.
Do they have replacement sources in?
Energy's got to come from somewhere. What my colleagues and I have done, and this is the little talk. And we didn't get to record it, but the talk that I gave to Senator Daines' assistant a couple of weeks ago, I showed her the basic strategy that we have for taking pine beetle kill out of the forest, turning that into a biofilter. That biofilter is then attached to a coal-fired power plant that then sequesters carbon. That carbon can then be turned into an agricultural product. So you're basically taking what was going to be burned and sent up into the sky and putting it back in the soil where it becomes a nutrient. So,
I have a question about that.
yeah.
Does that capture the heavy metals and mercury?
Yeah, that's another question. You would want a catalytic process for pulling off the heavy metals, and because if you've got this, and another option too for that is, let's say that you are using your biofilter to capture heavy metals, that entire biofilter itself can then become a fuel for the next round of combustion. Well, you've already got the mercury in there, and so again, your two strategies are either concentration or dilution. Any single process is going to do one or the other. It's either going to concentrate chemical entities or dilute them. And so the idea there would be, well, if you've got some mercury in there, let's just keep that dirty fuel packaged or contained. It's not unlike what we've been talking about with nuclear so far. Like just keep the stuff on site, figure out some new way to use it. Sounds like even Gates wants to do something with U-239, because there's a lot of excess U-239 sitting around. So keep it in the stream. Keep it local. Don't send it all over, and concentrate it. So I guess what I could foresee would be if you have a filter that's becoming oversaturated with mercury, then ultimately something else has to happen to it. I mean, you send it to a process where the mercury is now at a high enough concentration level that it's now economically feasible to extract that as a pure substance rather than an impurity that's screwing up your filter. So I think you have to look at it both ways. But yeah, it's a great question. Yeah, because you really don't want to be spreading mercury on your crops, for example, or lead for that. So the heavy metals need to be dealt with separately. That's a great question, though. Okay, so that's going on, and then I am going to have a work party at the house. I think I set it for Monday, the 14th. Is that right? Monday? Did you guys get that email? Let me just check really quick.
2 weeks from yesterday?
Yeah, just sort of everything's sort of converging right now, but yes, this is finals week. We're going to do a zero waste event at the Adams Center on the 13th. If you can make that, great. We would love to have volunteers. We're just going to keep all of the waste from the Maid Fair out of the landfill. So it'll be fully recycled, turned into energy, or turned into compost. That'll be the fate of all the stuff from the Maid Fair. And then the next day, we will discuss projects that could happen on 8 Columbine in terms of energy efficiency or other energy technologies. And if anybody wants to turn those projects into an undergraduate research, so NRGY 290 undergraduate research, say, hey, I'm going to put in however many hours, I'm going to write a little report, and then you get a credit or two. There's a lot of times students like, hey, I want to do a project over winter break, You won't sign up for it over winter break because there's nothing on the books, but you would complete the work over winter break, sign up for it over spring session, spend a few hours summarizing what you did over winter break, and then you get your credit for it that way, if you're interested. So that's what we'll do at my house on the 14th, because on the 18th, I'm leaving town for about a month. And so I've got one former student who's going to be sort of the caretaker, if you will. Hopefully he doesn't go Jack Nicholson on anybody up there. But it's funny because I don't know if you guys read the book. This was not in the movie, but in the book The Shining, he was constantly battling the boiler. If you get a chance, read the book, because there's a boiler that's like noisy and clanking, and he's fighting his alcoholism, and he's getting these headaches, and the boiler's banging, and it drives the man insane. And then and the whole murder scene was very different in the book, but my boiler's broken too, and I'm just I'm just hoping the I mean, I know the guy very well who's staying there, and he's a very thin-blooded Georgian. We got firewood. We got two fireplaces. So anyway, he'll be there over winter break, trying to stay sane. What's that?
What time is that?
I've just got it starting at 8 a.m. Tynan and going through later in the day. In fact, it doesn't matter to me.
I have a final at 8.
That's, yeah, and again, it is not mandatory at all. Oops, I don't want to do that.
Unless I'm just in what I want.
Yeah, it is not mandatory. There's no, you don't have to check in, check out. It's just an event. So it'd be great to see you. You won't hurt my feelings if not. So okay, so that's day in the life. Where are we on time? Okay. Well, with that, let's just go ahead and dive into chapter 13. I think we're mostly caught up on summaries and problem sets. I think Tim did a pretty good job covering problem sets with you last week. So keep plugging away on that. Let's just go ahead and dive into chapter 13. So really, up to now, we've been covering the fundamentals of a lot of different technologies. We've covered a lot of physics. We've covered a lot of energy technology history. I think to a large, we've talked a little bit about money. We've talked a little bit about how energy technology projects get funded. We've also talked a little bit about how they get paid back. Now we're going to talk a little bit about other costs that are not monetary, but costs to the environment. And if you get a chance, I'm just going to make a quick plug for a book. If you're looking for something to read over winter break, take a look at this book. I happen to know the former husband of one of the co-authors. So Monica Ricks Paxson, I have not met her, but I've met her ex-husband, Steve Corrick, who's a good friend of mine. Corrick recommended this book because it takes a really big picture. So in NRGY 101, we take a pretty big look at energy technology. We're looking, at energy flows through civilization. This takes an even bigger look at sort of energy flows through solar systems, and one of the things, and it gets a little bit kooky, a little bit aliens, but no one has yet disproven that there were never aliens in this solar system, and the solar system's been around a heck of a lot longer than our little 70,000-year-old selves. But what these authors propose is that they're actually looking at what's called the panspermia hypothesis. So if you think back to Watson and Crick, Nobel Prize, discoverers of DNA, 1953. Crick, who, God, I think maybe he did finally recently, no, I think Crick died not too long, anyway, proposed that DNA got to planet Earth from something that flew through space and just sort of, landed here and started replicating rather than life originating on Earth. A lot of time, if you go back in all traditions, humans used to be, the culmination of evolution. We didn't, we were created at the hand of God, et cetera, et cetera. The Earth was at the center of the universe. We're the center, we're the focus. Crick took it one step further. So you know what? Life didn't even start here. It started somewhere else and sort of blew in the cosmic winds and landed here. Well, if it landed here, it also landed on Mars, and it also landed on Venus, when Mars had more water and Venus was a lot cooler. And that really not through any fault of life itself on those planets, life became extinct. Just the conditions were not correct for it to flourish. On Earth, on the other hand, it has and continues to flourish. The question is for how long? How long can we get away with our nature exploiting practices and still thrive, survive, etc. So anyway, that's what that book's about. I encourage you to take a look at it because it's an even bigger picture on sustainability. It's sort of sustainability at the cosmic level. Maybe, and I haven't seen the movie The Martian yet, but I'm guessing there might be similar themes. There's also a fair amount of scientific rigor in this book. So they talk about how, like the politics of science a little bit, how the algorithm, the computer algorithms that these guys wrote to process the images that were coming back from some of the first scans of the Martian surface were very controversial because what they were proposing is that there were actual structures, there were artificial structures on Mars. They weren't natural. These structures were sort of built by some very ancient civilization. And how do you know until you look, right? I mean, lots of very smart people have thought the same thing over millennia. So they talk about how their scientific theory was called into question by some very emotional individuals rather than sound thinking, just the way science is supposed to go forward. Okay.
Probably religious.
Sometimes a little religion gets thrown in there and confuses the whole thing. Okay. Well, the reason I mentioned all of that is this very first picture in the book, right at the end of 13.2, talks about tanker spills, and they're by size, more or less. And I do not pretend to know all of the downsides of what goes on when oil is spilled. Of course, you've seen the plumage of birds is affected, then the bird can't fly, and it kind of falls out of the ecosystem. It could be that there are some forms of life that actually thrive on oil in the ocean. I am not aware of what they are, but in general, you look at these oil spills as a threat to the biosphere. They're more or less poisoning what was happily living, breathing, swimming, etc. The other thing I want to mention is that all of these spills were driven by somebody needing to put gasoline in their car somewhere, right? So the point is, like, I got to get to work or I'm not going to get paid. If I don't get paid, I can't have any money. If I don't have any money, I can't put any gas in my car. If I don't put any gas in my car, I can't get to work. If I can't get to work, I can't get paid. So the economy is driving the transportation of fossil fuels around the planet. But in this book, the The quote from the book that struck me the hardest, and I'll just write it down, and again, I'm not going to claim to be an economist, but pure economics takes a very large look at everything. And one thing that came out of that book is that the environment is the economy. That's what came out of this guy, and the lead author is Brandon Berg. Again, I think my buddy Steve Korek knows him. But when you hear something like that, it sinks in. Now, when you read this last paper, of mine, I have 3 equations in there, and I'm just going to go ahead and write them because I think they're relevant to this statement and to this chapter. In that paper, I look at 3 variables. I look at entropy, which is S, and that's just heat divided by temperature. We've looked at that, or changes in heat divided by changes in temperature, or the temperature where something's happening. I look at information, which I think we're all familiar with. In fact, we're using information streaming through my computer right now, through the LCD projector, up onto the screen, out through YouTube to communicate. That transmission of information requires energy. There's electrons flowing out of this battery. They're coming into the walls right now, and Colstrip is still on fire. And there's money. So information is just measured in bits, and money is measured in dollars. So whatever, dollars, money, what have you. In my mind, the environment is this kind of, this fits under this umbrella of entropy, because as we put heat into the environment, we are entropicizing it. There's also, as life becomes more complex, just think of all the life that has happened on Earth, like all of the species that have emerged and become extinct. Just think of all these waves of life that have happened on Earth. It's very unlikely that those would happen. You go look somewhere else. Do you see it? No. So life itself is sort of anti-entropy. It's unlikely. It's like life is a very rare, precious, unlikely, fragile thing. And so, I see life on Earth as a de-entropicizing effect, an ordering effect. And I think it's time that our species actually wakes up and says it's really our job as humans to be the gardeners of this Eden we've been given. So that's my entropy view. And then the economy obviously is dollars, right? Sits under that umbrella. What's in between? Well, in my mind, information sits right in between those two, because when I get my paycheck, I don't walk over to Lomason and they hand me a big stack of bills or a block of gold or a few dozen eggs. They just put a few more ones and zeros in a computer somewhere at the Missoula Federal Credit Union, right? And then I go to the Home Depot and I swipe my magnetic strip and some ones and zeros fly through their machine and some other ones and zeros come off another machine. So in a sense, money now is just information. Sure, it takes other form, commodities, but and honestly, money has always just been information. It's just been what we agree to in our courts, in our banks, in our system. But also, and if you were listening to, say, National Public Radio last night, you might have been hearing about all the climate modeling that goes on. So the very first crude climate models were happening in the 60s, and then they became more advanced, and computers became more advanced. And so now we're actually able to model with information the entropization of the environment. We're able to say, oh gosh, look at this, worldometers, right? You know, look how many forests are lost. Look how many, how much CO2 is going in the atmosphere. Just look at all these environmental factors, and we can measure it. We can turn it into bits and throw it out there. So information sort of sits right between entropy, which is physical and real, and money, which also can be turned into something physical and real. Okay, so the environment is the economy, and here we have the economy, which I just sort of explained as this cycle, causing the actual environment to be degraded. And so if you watch, you know, Al Gore's, what was that, Inconvenient Truth, he had the planet on one side of the scale and the pot of gold was on the other, and how do you balance it? Well, what Paxson and Brandenburg said is they're the same thing. And so, okay. Hope my point was made there. All right, now let's look at some of the costs. I don't have a figure on this, but I do want you to pay attention to several things in this chapter, many of which will be on the exam. So I'm just going to look at 13.2 on page 506, and it says there are various criteria, this is just right above where it says by scale, various criteria that can be used to analyze and classify the impacts of energy use, including scale, so how big it is, you know, is it a coal-fired power plant, or is it the fact that you littered in your own backyard, I don't know. So source, you know, where's it coming from, is it from fracking, is it from coal mining, is it from oil production, is it from uranium mining, gold mining, where is the pollution coming from? And then public concern too, because, you know, the public is not necessarily aware about even what particular pollutions are until it becomes an epidemic and something, like the whole lead poisoning thing, people didn't know for a while. So those are different ways to categorize it. Now, by scale, and then again, they sort of start big and go small, so what's happening around the planet, what's happening around the region. They mentioned acid rain, for example, SOx and NOx coming out of coal-fired power plant. The community, talking a little bit about the inversion here, the fact that Missoula actually does receive federal dollars for the organization known as Missoula in Motion, because we have similar air quality issues to what Los Angeles has had and Beijing continues to have. Workplace, we had an environmental issue in our own workplace. We built a solar thermal heat exchanger a few years ago. Got so hot, it melted the polystyrene, and now we're breathing VOCs. Smell a lot like the carpet does in this room. Not good. So it could be a workplace issue. We've since fixed it. Or the household emissions, smoke or pollutants from wood burning. I'm doing a lot of wood burning at my house right now because the top loop, my boiler, is down. The bleeder valve's busted, and it's not clear if the pump is broken or if the pressure regulator is broken and not making enough pressure to make it up to the top floor. So I've been burning a lot of wood in the fireplace.
Checked home resource?
What's that?
Checked home resource?
I've checked Brian Daughtery, who's one of your classmates here. He works on facilities. He's brought me a new bleeder valve, and he's going to come up and help me with it.
Nice.
Yeah, I've been busy making breakfasts and lunch for the kids because no one wants it. Okay, so those are by scale, you know, big down to small. By source, and this is table 13.1. So what they're really doing is rolling through every single energy technology we've covered so far and then some. The first several are from this book, so oil, natural gas, coal, nuclear, and the rest are from the technologies that you'll learn about in NRG Y102. Biomass, hydroelectric, wind power, tidal, geothermal, and solar, all of which are renewable. And I'm just going to pick one of them, because you might think, gosh, how can geothermal energy be a pollutant? Well, says right here, release of polluting gases such as SOx, hydrogen sulfide, and et cetera. Now, this is if you're drilling deep, right? So if you're doing a deep well, some of these gases might be trapped in the rock strata. Here they come. Groundwater pollution by chemicals. How would that happen? You're thinking, well, it's just geothermal. How would you do that?
Some of that getting off into clean aquifers.
Yeah, I think that's more or less what it is, and it was a little bit of a head scratcher for me, but a lot of times what you'll see with geothermal, in fact, our own geothermal system at the university has this. I don't know how much environmental monitoring is going on, but here's here's your building, here's your loop. And really what we're doing here is we're just sending water down and sending water up. So the groundwater, let's just say we've got an aquifer down here, right? So this is soil, rock, strata, what have you. And here's your aquifer down low, because the water is going to percolate, find its way down, and then head off into the rivers and streams. Well, it's going to be to your advantage from a heat transfer point of view to have your coils, your heat transfer coils, sitting in water rather than in rock. It's just better thermodynamics. But if you have just sent your drill, through the rock strata, now those crumbs, crud, whatever, and you don't know what was in there. Everything's in rock. That could now be in your aquifer. And so now the next guy down here who's got his kitchen sink hooked in has to, be downstream of that. I think once you've got your geothermal in place, not a big deal. But who knows? Maybe this thing's got exposed copper in it. You get too much copper in your body and you die. In fact, there's a gal worked over here at Subaru, died a few years ago from copper toxicity. It was weird. She was there one day, the next week she wasn't, and she had too much copper in her system.
Well, when we lived in Gardner, we couldn't drink the well water.
Yeah.
We could use it for bathing.
What was in it? Do you know?
Can't tell you everything, but
Yeah.
We just had to go get jugs of water from the Forest Service faucet outside where they had good water.
Another thing too, you've probably heard of dioxins. So dioxins are a class of chemicals that have a lot of chlorine. You've got chloride ions sticking off of there. Number 3 plastic is PVC. It's the only coated 1 through 7 that I know of that has a chlorine in it. And so if you've got a PVC loop down here, there's a slight chance you might get dioxins in your aquifer. And there's a lot, I think California is pretty dang close to just outlawing PVC entirely because of the dioxins. Okay.
So just piping, just even using that pipe?
Yeah, the pipe.
Stable?
Well, it's a good question. Is it stable or not? Give it 1,000 years. I mean, seriously. I mean, everything degrades.
Right.
Every single thing around us we see right now is eroding in some way or another. So it has a certain level, just like we did with our half-life problems. Eventually, it goes away. Like just matter, molecules, bonds eventually degrade, and they have to go somewhere. So it is stable, but how stable is the question, and how much dioxin are you willing to tolerate? Yeah. Okay. Then impact categories. So you'll want to know the difference between mortality and morbidity. So mortality means it will kill you. Go out and drink a whole jar of arsenic and you will die. Go out and breathe some VOCs or get a little bit of lead in your system and you're your neural function will be compromised, but it won't kill you. You know, you might take a few years off your, you know, breathing pollution in downtown Beijing might not kill you right away, but chances are you're not going to live as long as somebody who was not, you know, breathing all the crud in the air. So that's the difference between mortality and morbidity. And I think there's always there's one funky question in here. I don't know if it's in this table or not. There's another question that gives people all kinds of grief, and I think it has to do with the relative amount versus the absolute amount of something. And I want to say it has something to do with oil spilled in the ocean. So when you're reading through these different contaminants, please try to keep in mind two separate things. What's the absolute magnitude of something, and what's the relative magnitude of something? But no, this is a great chapter. Okay, and then public concern is mentioned. So loss of biodiversity, some people think that's a big deal, some don't. And in the end of the day, it actually probably doesn't matter what people think or not. It will have whatever effect it does. There are scientists like E.O. Wilson who say that it's the loss of biodiversity problem is much greater than we currently know.
Racing Extinction tomorrow.
What is it?
Racing Extinction.
Oh, is it a movie?
It's a documentary on the
Oh, yeah?
Discovery Channel.
Which channel?
Discovery.
Oh, Discovery, okay. Racing Extinction?
Racing.
Cool.
Yeah, it's a bunch of scientists go around and record a bunch of bad stuff and then talk about how we're the only generation that can fix it because the future one isn't going to be here if we don't.
Oh. I had a very similar conversation yesterday with this guy from Vancouver, and you know, a lot of times in this class I'll say throw around some big scary numbers, but this guy was for real. I mean, it was like being with Gandalf or something. It was, I don't know. But it's a great point, though. If we don't save the biodiversity, then it becomes a moot point for future generations. They won't be here because they depend on it. Is that what you're? Yeah. Our own. Yeah. Interesting.
I have a question for you.
Sure.
So by 2030, the Clean Power Plan that was signed in August says the economic impacts of, say, IGCC, the carbon capture and sequestration projects going on for coal-fired power plants will lose approximately 50,000 jobs in the U.S. However, sustainable jobs will create about 83,000.
Okay.
But the sustainable jobs won't be created as fast as people are losing jobs.
Oh.
So do you think it is beneficial to put on, say, the CCS technology onto coal plants, or just get rid of coal plants in general for?
Funny you should mention that. So I'll repeat Tynan's question for the non-live studio audience. So what you're saying is that the loss of conventional power will result in, let's just say 50,000 jobs nationwide, somewhere, whatever, but that the Clean Power Plan will bring on 80-some thousand new jobs in renewable energy, which sounds like great news, but you said the downside is that the 50,000 will be lost faster than the 80,000 come online, which is bad news because you'll have this shock to the economy that we'll have to ripple effect from. Your follow-up question is, can we remediate the coal-fired power plants and keep them alive so that the job attrition is slower? Is that kind of and my answer to that is absolutely. And what happened in our meeting yesterday, where the scientists, technologists, clean technologist from BC was down here with his process that is carbon positive. So they're still emitting CO2 from their technology, and the one that I've developed with, well, I shouldn't say I've developed, the one that I've been studying and promoting with my colleagues in the Bitterroot is, I don't want to say it's carbon negative, but it is a CCUS. It's a carbon capture, utilization, and sequestration technology. You'll see more and more of that, CCUS, carbon capture, utilization, and sequestration. It is a CCUS technology. And what we would like to do is to remediate the emissions from a coal-fired power plant. And all of a sudden, it sort of occurred to us is that Colstrip is about to become a liability. It was in the asset books, right? Because it's making all this money, making all this electricity. People are paying their utility bills, et cetera. But it's about to become a planetary liability that's now in the red instead of the black column. Well, at that point, here you go, right? So who wants it? It's a hot potato, right? And we think, and this was the conversation that I had with Dane's representative or assistant last week, is that we think we could fix it. I mean, we think we can actually. So we would like to see it be a bridging technology rather than an either-or kind of thing. And just to speak in engineering terms, mathematical terms, I think things tend to go more smoothly if they are Gaussian curves. We saw the Gaussian before when we looked at Hubert's peak oil, rather than what's known as the Heaviside step function. Right? Because this makes for predictability. Smooth transitions, and this is a shock, right? So, in general, nature, economics tolerates this kind of curve much better than this one. So, what I hope doesn't happen is just like, okay, guys, Colstrip's shutting down tomorrow. All 7,000 of you, and your $500 million per year economy. We'll find some. I don't think that's the proper way to do it. It would be much better to ease this in, and we already have a prototype working, and we'd like to have the opportunity to continue to do so.
With the sequestration part, do you think that it's viable for the EOR, the enhanced oil recovery, like they're doing in Mississippi and Texas, where they're capturing the carbon and then sending it down for enhanced oil recovery? Yep. Do you think that's beneficial? Do you think Colstrip will start doing that?
Well, there's already a 200-mile pipeline between Wyoming and Montana that's doing that. So we're already doing some EOR right here. And, I guess my view of that is it's a self-perpetuating process. It never ends, right? You keep burning the carbon to make the CO2, to send it back underground, to bring up more carbon, et cetera. So it sort of never dies. So my philosophy now is one where I would much rather see those fossil fuels just stay in the ground longer and just die a long, slow death. I think we know enough about climate models now that if we just we take this thing and just let it do something like this. We know what the effects of burning it are. And if it turns out somewhere in the future where, gosh, I don't know, volcano blows up, sends a lot of dust in the air, gets cold, and the sun doesn't shine for a few years, gets cold, fire those coal-fired power plants up, and rewarm the atmosphere. So I think we know what the effects are, and so my take on it is it would be more valuable to leave those fossil fuels for future generations if they need to warm the planet on a global scale, which is what we're doing right now. Okay, let's take a break.
Thanks.
Yeah.